So magnetic field as well as the magnetic induction. So what is B value? But the thing is that here, if you want to calculate the B value, here the basement is the Gauss law. Gauss law. But here that law is Ampere's law. Okay, Andy? So this is Ampere's law. But somewhat in some cases, if the field is uniform and whatever the material, the conducting material, if it is in a particular length, uh, there itself we are going to be using Ampere's law. But if it is the length of the conductor is which is in not irregular, and the electric field is also in not in a uniform condition, so that in that particular case, if you use this Ampere's law, that law is not applicable to find out the capital B value. Okay. So there itself another law which was introduced, that law is the Biot-Savart's law. By using this Biot-Savart's law, you can easily find out the B values. Okay. But the thing is that here, what is the what I say? Wait a minute. So here magnetic flux. B dot ds. You can see electric flux suffix E is there. Magnetic flux suffix B is there. Flux. Okay. The number of line of force of field which is crossing the unit area and the direction which is perpendicular to it, then you can call it as a flux. The definition is same. But the thing is that here, whether it is in a electric field or else it is in a magnetic field, that is depending upon that you are writing this equation. Here E, here B. Getting my point? Here E, suffix E, here B is there. The same thing. So you need to calculate by using Gauss law here. Here two laws are there. You are going to find out the B value. Is it okay now? Before going to discuss the concept, let you know what is the main idea in this magnetostatics, what you have to calculate. That's it. So in this Ampere's law, there is a magnetic field. How much of the effect of the field which can be occupied by such a region, you can call it as a magnetic field. The same definition here also you can implement. But there itself we have been using the point charges. But here the poles, that is a north pole and south pole, that there should be a attraction or repulsion. Okay. Same poles, always you know pretty well there is a repulsive force. Opposite poles they may be attracting. Okay, Nandi? So here you need to find out that. So what is the definition of the B? What are the units of the B here? And what is Ampere's law which is going to be denoting here? How to find out the capital B by using a point charge when it is going to be passing through a current carrying conductor. That will come into the picture that was set by the Ørsted. And magnetic lines. So first of all, I'll let you go for the introduction here. Why? Because of uh, the you know pretty well what is the relation between the capital E and B and E. E is the electric field and B is the magnetic field, which is always perpendicular to each other. Most important objective bit when you are going to be attempting any competitive examinations, there itself so many times this question is asked. Perpendicular means 90 degrees. Okay. Electric field as well as the magnetic field both are perpendicular to each other. So the thing is that here in magnetism or else the magnetic phenomena, the olden scientists they have been performed so many experiments. In 16th century, English physicist Gilbert, okay, uh, he studied the properties of the magnets, and also He realized that there should be existence of the magnetic field around the earth here, and this nature field which was also similar to the magnetic field as well as around the magnetic sphere. But later on, he is in 16th century. Whenever 18th century, that means approximately 1820, Ørsted, he is another physicist. Okay, he discovered that a current carrying conductor may produce a magnetic field. What he said? A current carrying conductor which may produce the magnetic field. That was said by the Ørsted. Based on the Ørsted, Ampere come into the picture. Okay. So the basement is the Ørsted experiment. Current carrying conductor. Next, Faraday is also vice versa. Vice versa means whenever a magnetic field which is applying to the current carrying conductor, there should be electric field is generated. That is vice versa experiment. Okay. Ørsted said that current carrying conductor may produce the magnetic field, but whereas Faraday, when the magnetic field is applied to current carrying conductor, there should be electric field is going to be generated. Okay, but the thing is that here in which direction? Perpendicular. That is very, very important. So you can go for this magnetic field here, a current carrying conductor according to the Ørsted, which may produce the magnetic field. If you want to calculate the intensity of the magnetic field here, in which direction you have to apply the magnetic field, which can be represented by capital V, and you can call it as a B is also a magnetic induction here. And how the capital B value, that means the B which is a tangent to the line of the induction here, magnetic induction at any point, and the direction B at that particular point here. So that here in this case, just now we already told you that this is not phi into B, phi B, suffix rayale, suffix phi B. Print mistake here also. So phi B, surface integral B dot ds, B surface integral ds, B A. So phi B is nothing but a BA or B equals to phi B by A. Okay, Andy? So phi B which is measured in Weber, and area which is in meter square, Weber per meter square is nothing but a Gauss. Okay, Weber per meter square, Weber per meter square is 1 Gauss, 10 power 4 Gauss, 1 Tesla. Okay, so this is also phi B, and this is not 104, 10 power 4. So many printing mistakes are there. You can go for that. Please do corrections. So 10 power 4 Gauss is nothing but a Tesla. I think so nowadays we are using the Tesla word. So Elon Musk, Tesla car. Okay, there itself. That means which is related to the magnetic field or the magnetic induction. You need to immediately say, tell that here. Anybody, if it is going to be asking that, definitely we have to say that there should be a relation between the magnetic induction or magnetic field to the area. That you can call it as a Tesla 10 power 4 times 10 power 4. Okay, which may gives you a Tesla here. This you can call it as a Gauss. 10 power 4 Gauss is nothing but a Tesla. Like that you have to tell. Next definition of the B here. So, whereas in electric field, uh, suppose if you consider a positive charge like this, the line of force of field which is always in outwards, like this, how much of the effect of the charge which can be occupied by such a region, capital E. What are these lines which are indicated? FF, line of force of field. This is the electric field. But here also, how much of the effect of the attraction or repulsion which can be takes place by such a region, you can call it as a B here. Okay, Andy? Like that you have to. So for the magnetic induction or the magnetic field here, when a magnetic needle which is brought to the near the current carrying conductor, uh, that means magnetic needle means compass. Compass. So there itself it can have a needles here, south pole as well as the north pole. So that if it is going to be carrying toward the current carrying conductor, what will takes place here? There is a deflection is going to be takes place, whether it is in a clockwise direction or else in the anti-clockwise direction. The needle is going to be deflecting. That means somewhat it is going to be present inside it. That you have to identify. That means deflection is going to be takes place in clockwise or else the anti-clockwise means where else same poles which are to be poles with respect to the poles. If it is a north pole, south pole, or else north pole, this is the south pole. These are the bar magnets. Okay. Whenever you are going to be takes place south and south, there is a repulsive force. Okay. That means a deflection should be in opposite anti-clockwise direction. Clockwise direction, if you place the south and north pole which moves towards the south, there is a attraction between this. Like that, in electric field is also, if it is a positive charge, another positive charge, if it is going to be moving takes place, there is a repulsive force. If there is a positive and another one is a negative, there is a attraction between them. Okay. So the magnetic field which is produced near the wire and it is moving the charge produce the magnetic field. Therefore, electric field is also produced due to the charge. Hence, the magnetism and electricity, which are two aspects when a current carrying conductor which is going to be produce the magnetic field. In that particular case, current carrying electric field which may produce magnetic field, magnetism. Two aspects are there. Okay. So here, if a point change which is going to be moving the magnetic field and it is also going to be experiences such a force and which is in the perpendicular direction. So that what is the maximum force which is going to be takes place when the direction of the capital B and as well as the velocity of the particle which are perpendicular to each other. There itself maximum is velocity, and if it is 0 means both are in same direction. Okay. So 0 means theta value 0 degrees and here theta is 90 degrees. So the perpendicular direction, that is sine value. Sine 90 is 1. There itself it is maximum. So when it is both are parallel means theta is 0. Sine 0 is 0. That's what there is no uh, force value. So here the condition F equals to QVB sin theta or else QV cross B. Why A cross B? Cross product and A dot B. Okay, dot product. This is cross product. That's what simply let you say that this is A, this is B. AB sin theta means A cross B. So from this equation, B equals to F by QV, force which is always in Newton per second. Okay. And QV, charge which is measured in coulombs, velocity here meter per second. That's what here it is going to be Newton second per coulomb meter. Okay. force which is Q is in Coulomb um, meter per second. Okay. So that Newton second per Coulomb meter. Newton second, not per. Some mistakes are there, you can correct it. So that the electricity as well as the magnetic field, electric field and magnetic field, both these two are to be existed in the case of if you want to calculate the F value. So the particle is Lorentz force. What type of force is? Most important bit. This is the equation for the Lorentz force. F equals to QE. Where it you have been seen in the Gauss law itself, intensity of the electric field. The ratio of the magnitude of the force to the charge is nothing but intensity of the electric field. From this F equals to QE. This is the one equation. Another one is the F equals to QE cross B. Not into QE cross B. Cross on చదవాలి. So the total force which is F equals to total అన్నాను. Total అంటే sum. QE plus QE cross B. This force you can call it as a Lorentz force. Next, Ampere's law. So by using the Ampere's law, you can easily find out the here magnetic field value. Capital B value in calculate చేయొచ్చు ఈజీగా. What is that equation? Line integral, line అన్నాను. Only one dimensional. Surface means two dimensional. Volume means three dimensional. Okay. So line to surface అంటే vector analysis లో ఆల్రెడీ చదివాం మనం. Stokes theorem. Surface to volume అంటే Gauss divergence theorem. ఓకే అండి, ఇవన్నీ గుర్తుపెట్టుకోవాలి. సో in the discussion of the Ampere's law, when an electric current which is going to be flowing through a current carrying conductor, then three kinds of effects are going to be takes place. One is the magnetic effect, another one is the heating effect, third one is the chemical reaction or chemical effect. Three effects are going to be takes place: magnetic, heating, chemical. So any one of these methods which are to be using to measure the strength of the currents. Okay. So whereas in the case of Ørsted, he has been observed that magnetic needle which is going to be placing toward the current carrying conductor, needle is going to be deflecting from its north to south pole, indicating that an electric field is going to be produced by the magnetic field. And if it is going to be reverse the current here, the deflection which may takes place in the opposite direction. Okay. So Laplace as well as the Ampere, these two scientists showed that the law of intensity of the field which is due to a current carrying a linear conductor is which is in mathematical form. Okay. Linear conductor, not in a complex. So there itself it is using a Ampere's law. The field is also uniform. There itself it is a Ampere's law. If the field is not in a uniform, when the conductor is not in a linear, there itself the Ampere's law is not applicable for that particular case. So there we are using the Biot-Savart law. So here Ampere's law, which is always the line integral of the magnetic field or magnetic induction, which is always equals to the mu naught times the current passing through the same conductor. So this it is going to be stating the Ampere's law. This is the case. Statement రాయాలి, దాని నుంచి మనము ఈక్వేషన్ రాబట్టాలి. And here for a dipole, what do you mean by dipole? Two equal and opposite charges which are to be separated by such a distance, that setup you can call it as a dipole. Okay. So in this a dipole which is going to be uh, torn in a magnetic field by making an angle theta with that equilibrium position, there itself such a torque, you not need not to be say that that is a force, that is a torque tau. Okay. And you must be able to enough to overcome the restoring torque, and that will be act upon the dipole here. So theta is the deflection angle here, torque tau is the torque, and B is the magnetic induction of the magnetic field. What is the relation between them is tau equals to mu B sin theta, or else A B sin theta is A cross B, vector notation, mu cross B, where mu is the magnetic moment of the dipole. Magnetic moment of the dipole. Okay. So we can obtain the mu value as well as the theta value is also there. Why? Because of where theta is the angle between the mu and B. And also if the conductor which is allowing such a current through it, mu will be a constant for a given dipole. So the B value which is always proportional to it, so that I by R which is always proportional to it, and if it is uh, experiences the total value which we may be equating a proportionality constant, that is a mu naught by 2 pi, you may have uh, what is that, and ఇదే equation నుంచి b into 2 pi r mu naught I. But what is the Ampere's law? But what is the DL value? Getting my point? DL value by equating these two. Like that. I. And what is the permeability? Mu naught, what is your mu? In electrostatics, epsilon naught, permittivity. In magnetostatics, permeability. Okay, Nick? So if you want to calculate the magnetic field, uh, at a point due to the current carrying straight wire, there itself, if you want to calculate it, the conducting wire which may be offering such a current, that current value is I. And if you want to calculate the B value, let us assume that a small elemental length dl of the current, it is going to be produces the magnetic induction is dB, which is situated at a distance small r from the conducting wire. There itself, if you calculate that value, by integrating it, you will get the entire current conducting material. Okay. So dB equals to mu naught into mu naught by 2 pi, here 2 pi, and dl sin theta by r square. So mu naught I by minus 90 to plus 90 degrees cos theta d theta. This may be writing like this. Okay. Sin theta may be written as cos theta d theta. So remaining is, by simplifying it, you may get this equation like this.